All right, solving rational equations. So today we're going to look not at rational expressions, but rational expressions with an equal sign between them. So they become rational equations. And the nice thing about these is that they're really similar to what we reviewed yesterday. So 3 over m squared equals m minus 4 over m squared plus 2 over m squared. Oops. Sorry. This is number 1 on your homework. So what we want to do here typically is use that trick that Gary gave us to just clear out our denominators. Now that's not the only way of solving these, right? We know how to combine these. We could add these together, right?
It seems like a lot of work.
But yeah, it's a lot more work.
We can just multiply them all by m.
So what we want to try to do,
3m.
yeah, is clear out the least common denominator. So what I think to myself is, okay, if I were going to add all of these together, what would my denominator be? 3m squared, right? So what I would do is multiply this one times 3 over 3. But I'm not going to do that. I'm not actually going to multiply to make equivalent fractions. When we added and subtracted rational expressions, we made equivalent fractions. You don't have to do that step now. What you do instead is you just multiply every term times what would be your least common denominator. So I multiply every term times 3m squared. Now, what will usually happen is some of that factor that you multiply it times will cancel, but not always all of it. So in this fraction, it all cancels, right? In this fraction, it all cancels. In this fraction, just the m squared cancels. So then over here I have 3 times 3, yeah.
Wait, if you multiply 2 on the right side, wouldn't you have to multiply 2 on the left side?
So technically what I'm doing is this. 3m squared times something, right? Something equals something times 3m squared. So the reason I multiply it times both of these is because of the distributive property. That's a really good question, right? So I'm skipping this step. Okay, I multiply this side times 3m squared, and then I distribute the 3m squared to both things in the parentheses. The overall effect is I multiply every single term times 3m squared. Does that answer your question? Distributive property? Leo?
Yeah. Yes.
So we just distribute. Okay. All right, so what am I left with? Well, on the left, I just have 3 times 3, which is 9. And on the right, everything canceled from the denominator, so I just have those numerators left. You can solve this. Okay. So if we have m minus 4 plus 2, that's the same thing as m minus 2. If I add 2 to both sides, m would equal 11. Now there is one last step here. When would m not equal 11? Well, if 11...
Wait, what did you do with 2? What happened to the 4 right there?
So minus 4 plus 2 is the same as minus 2.
Okay, I was just like, you said plus 2, and that's not how that works. You don't go from plus m minus 4 plus 2 equals 11. So I heard you say something, and it didn't work out in my head. Okay.
Okay, you see it now?
Yeah.
Yeah, I went kind of fast on these steps. Because this stuff, I mean, this is like the beginning of last year, right? But when you get to the end, you do have to think, wait, what if 11 was an excluded value? Then that wouldn't be a solution. And now instead of calling it an excluded value, we call it an extraneous solution. So we just go back and we check, would 11 have made any of these denominators 0? If we plugged in 11 here, would this be 0?
No.
No. How about this one?
0.
No. And no. So we have no extraneous solution,
What
right?
does that mean?
No extraneous. Well, it's not an excluded value because we're doing something different, right?
I mean,
We're now-
because if m was 0, that would be your, like, your excluded value would be 0. You always have to write that notes.
No, don't write this, but if you have an extraneous solution, you just get rid of it. So let's say I said m equals 0 or 11 for some reason when I solved it. Then I would just say, oh, well, m equals 11.
Wait, why would you get 4?
If I had a quadratic equation here, if I had to solve a quadratic. Okay.
I think this is mean.
So again, this is a lot of review, right? It's a lot of review packed into one thing. Let's do another one directly from your homework.
Like, it's cool, but then it's like,
This one is number 7 on your homework. X minus 6 over x equals x plus 4 over x plus 1. Okay.
times it. Oh, that's not.
Multiply everything times what?
X.
X. Right? That's going to clear out all my denominators. And on this side, the x distributes to both terms. So now I have x cancels, x cancels. 1 times x is just going to give me x. So over here, I have x minus 6. Over here, I just have x plus 4.
2x plus 1.
And then over here, I have plus x.
So you could just do 2x.
Now I can combine my like terms. This is the same thing as 2x plus 4. This is x minus 6. And then maybe subtract x, subtract 4, and this would be negative 10, and this would be x. So x equals negative 10. Okay, would negative 10 make my denominator go to 0?
No.
So that's my answer.
Nate,
Yes.
are we going to have any that will make the extraneous solutions on our homework?
To be honest with you, I don't remember.
And then, what if you only have 1? Like, if it had, would you ever just get 1 where the extraneous value? Like, where it's an extraneous solution?
You could. Yeah, you could.
And what would you write?
I think that's possible.
No answer?
Yeah, you would just write no solution. Yeah, no solution. I'm actually not sure if that's possible or not, but I can't see right now why it wouldn't be. If it happened, you would just say no solution. All right, let's do number 11 on your homework. This one's a little bit more complicated. 1 over b squared minus 7b plus 10 plus 1 over b minus 2 equals 2 over b squared minus 7b plus 10. So,
So you could just multiply by times the b minus 7 plus 10 factor.
yeah, why though? Why?
There's the same one in two things.
all of the denominators.
Why will it clear out all the denominators?
Because, wait, but,
Can't you cancel the 10 with the 2?
No.
well,
Is 10 a factor of the bottom? Can I pull 10 out from here?
No, I mean like when you multiply them all by b squared minus 7b plus 10, can't you technically just cancel the b and the negative 2 out of the denominator because there's a 10?
yeah.
No. We can only cancel factors, right? We can't just cancel, like, I can't cancel this 2 with this 10, because I can't pull a 10 out of the denominator to cancel it.
But it's possible.
Yeah.
That's like saying, could I cancel this? 2 over 3 plus 2. Could I cancel these 2?
No, when you multiply.
I mean when you multiply
Yeah,
multiply everything by b squared minus 7b plus
Uh-huh.
10, and that second term right there, can't you cancel the 2 with the 10?
So that's like saying this. Could I cancel 3 plus 1 plus 2 over 3 plus 7 plus 10. Can I cancel the 2 and the 10 and the 3 and the 3? I can't. Because they're like terms, they're not factors. Right?
Well, you can technically cancel because it's 6 over 20, but
So this is 6 over 20, right? But if I tried to cancel this, right, 1 and 5, and don't do this. This is not allowed. Can't do it. Then I would get 3 over 13, which is not the same thing. So I have to cancel after I combine my like terms.
okay, but how would you get rid of that bottom?
Okay, so yeah, what do we do? Now, think about it. If I want to know what my common denominator is, I need to know what my factors of this quadratic are. What are the factors of b squared minus 7b plus 10?
5 and 2.
Yeah, b minus 5, b minus 2. So they do have something in common.
But how can you do that? You can't.
I'm just factoring the bottom. All I'm doing is factoring the bottom. I'm
But if you
simplifying.
do that, then you have to FOIL it, and it doesn't work.
I don't want to FOIL it. I want it
No.
factored.
If you multiply it, then you were saying like if you multiply two terms together,
Uh-huh.
then you have to FOIL it. You can't. just
Yeah,
add
if I
all the
wanted to
numbers.
multiply these, I would have to FOIL it.
No, if
Totally.
you multiply it times the other thing. Then.
Right. Okay, so let's get there. So my lowest common denominator is this. B minus 5 times B minus 2. So I'm going to rewrite this. What I really have here is this. This is what I really have. Because b minus 5 times b minus 2 is b squared minus 7b plus 10. Those are the same thing. So I'm going to multiply every term times this. I'm going to multiply every term times b minus 5, b minus 2.
Nate?
Yes.
So let's just say magically, your factors are b minus 5b plus 2. Like that wouldn't work with this problem.
Then it wouldn't
but
cancel, yeah.
magically, could you just pull out a negative 1?
No? Because that would be negative b plus 2, right? If we pulled out a negative, if we pulled out a negative 1. Good thinking, though. Okay, so now what happens? Now I have factors
It's 1.
that are the same in the top and bottom, right? This is a factor of the top and a factor of the bottom. Factor of the top, factor of the bottom. So I can cancel those. Over here, b minus 2 is a factor, and b minus 2 is a factor, so I cancel those. And then over here, those cancel. So it actually becomes really simple, and there is no FOIL now, because I just have 1 times b minus 5. So all I have here is 1 plus 1 times b minus 5, which is just b minus 5, equals 2. That's it.
B minus 4.
So I subtract 1 and add 5 to both sides. Minus 1 plus 5. And I find that b equals 6. Would 6 make this denominator go to 0?
No.
Oh, I didn't know.
No, it wouldn't.
So b equals 6. All right.
Wait. I
Yeah.
didn't get that.
Which part?
No, I mean I didn't. When you did it, when I did it in my head, it didn't come out like that. I got
Okay, what happened in your head?
I did it so that it's back up at when you just crossed out the stuff. So it was
Uh-huh.
1 plus 1 times b minus 5. So So in my head I was doing 1 plus 1 first, so that's 2. Then b minus 5 plus 2, which is b minus 3. So I got b equals 5 instead of 6.
Okay, yeah, so order of operations, right? We have to multiply the 1 before we can add the ones. Yeah. I mean, I totally could have written it that way. 1 plus 1 times b minus 5 equals 2. And then we just see, oh, 1 plus 1 has to wait for this distributive property. Does that make sense now?
Did we get our homework?
Questions, guys? So there's one other one that's similar to this, and then most of them are a little bit simpler on your homework. So look to see if you can factor the denominators first. Look to see if there's something that can be factored, and then look for your lowest common denominator.